Dear students, good evening. Under this process control instrumentation, we cover the two chapters in detail, right? And today uh, we'll see the third chapter, which is nothing but controllers, about controllers, right? And in this chapter, basically, we want to know what is a controller and what are its actions. What are its actions? And what type of control actions we want to know and we want to study, which are available in the process industries. So basically the third chapter deals with control actions, right? So you are all well know the subject like control system engineering in the second year, second semester, isn't it? So what is a control? What is a controller? And what is a control system? Any control system which includes a block like controller. So if you observe this, see the basic diagram of this. So this is what R refers to input. R refers to input or set point. Set point. And it is the error detector. Error detector. So it gives the error between reference input and feedback input. B refers to feedback input. So which is the output of the detector or error detector, nothing but error equals to R minus B, where E refers to error which can be calculated difference of the reference input and feedback input, right? Remember always R is nothing but reference input, which is also be called a set point, right? And this error is also called actuating signal, that is given to the controller. So for when the controller accepts the actuating signal, it responds accordingly. The controller gives some output P. P refers to controller output. So it responds as per the given error signal, which is also called actuating signal. Accordingly, the controller is going to be response. So the P is nothing but output of the controller. So P is also called output to the final control elements. Output to final control elements. You know, in the second chapter, we described that control system diagram completely. After the signal conversion, what is there? What is there? Actuator. Actuator, right? Actuator. Then after we have a final control element. Final control element. So we are talking about here a controller, only controller. So in this controller, input is error, output is a control action. That is called a control action. So in any control system, this is the main diagram which is going to be included. So why this diagram is included means for understanding the properties of the controller. We want to know the properties of the controller in detail, so that in a design of control system, you can place desired control actions for our desire, any process, for any desired process, right? See, in this, P is the output of the controller. Fine. So what type of control modes are available? This is called basic control actions. So in the control system engineering second year, second semester, we have studied that some basic control actions, right? Here also we have to recall once again what are the basic control actions are available in this. So the basic control actions also be called controller modes. Modes means what? Different actions, paths, different channels. How the controller is going to give some output by using different channels, different modes, different actions. Why we are specifically speaking about controller? Because for any control system, controller is the heart of the control system. Controller is the heart of the control system. So that you have to know clearly about the controller and what is a controller, what are the control actions, what are its modes, how it is going to be respond for a given input, for any given error signal. So that if you know this, you can easily understand um, the process is going on in any control system, right? And see the control modes, basically we can have two types of control actions. See, there are two types of control modes. The first one is discontinuous controller modes. Second one, continuous controller modes. Discontinuous controller modes and continuous controller modes. Actually, not only these two, we can have one more control action that is called composite controller mode. Here not we are not showing, but strictly speaking, the controller may have three actions. The first one is discontinuous control actions or controller mode, and second one is continuous controller mode. The third one is composite controller mode. Composite controller mode, right? We'll see what is the discontinuous control mode. Discontinuous controller modes. What do you mean by a discontinuous? If you understand what is continuous, you can take a opposite word is nothing but discontinuous. Discontinuous. So the controller action, the controller output is not continuous. Controller in the diagram, see, in the diagram here, P is the output of the controller, right? Output of the controller. So the P is not continuous. P is not continuous. But how it looks like the P? P is looks like discontinuous. Discontinuous means you can take any simple tap, water tap, water tap. If you turn like this, it's completely open. If you turn like this, completely closed. Completely open, completely closed. There is no option, no mediate option. There is no in-between options. Either it is open or it is completely closed. So that type of control actions are more so-called discontinuous controller modes. Discontinuous controller modes. So here in this diagram, P is completely open for such an input or completely closed for other inputs. That's the meaning of this control action. See, discontinuous means see the various controller modes that shows discontinuous changes in control output. Discontinuous changes in the control output. So here we have different discontinuous controller modes. Discontinuous controller modes. That is called, the first one is two-position controller, multi-position controller, and floating mode controller. Floating mode controller. So here in the discontinuous, there are three actions again: two positions, multi positions, and floating control and floating control. So the three comes under discontinuous. They are not continuous. They are not continuous. So you will see first what is two position. What is two position? In the two position, remember always, we are strictly speaking about controller actions. We are focusing on output of the controller. We are focusing on output of a controller, how it reacts, how it responds for some inputs. So how should be the output of the controller? We have to observe clearly. So in the discontinuous controller modes, the first one is two-position controller mode. What is two-position? Two-position means you observe this. Observe the equation. Control output P can be right 0%. Control output P can be right 100%. What is 0%? 0% means completely off. Completely off. So your controller is completely off. How it is off? When error is less than 0. When the error is less than 0, the output of controller is completely 0. 0%. No response. And when the error is greater than 0, the control output is 100%. So it responds 100% when error is greater than 0. If error is less than 0, it responds 0%. 0%. That is the meaning of this two position, on, off. See, the most elementary controller mode is on, off, or two position mode. On or off. When it is on, if error is greater than 0, it is on. When it is off, if error is less than 0, it is off. That is the meaning of two position. And one more is neutral zone. Neutral zone means, see, if you plot the diagram between error versus output, the graph looks like this. So the error 0 is starting here. This is positive error and this is negative error. And the control output from 0 to 100%. 0 to 100%. Okay. See, if error is less than 0, the controller output is 0. If error is greater than 0, up to some positive del EP, the control is 100%. Understand my point? See, if error is in between 0 and plus del EP nothing but error. In between these, no response, no control response. And in between 0 and minus del EP, no response. That is called neutral zone. So how it responds? When error is less than minus del EP, the controller is 0. If error is greater than plus del EP, the controller is going to respond 100%. In between these, the controller doesn't show any reaction, no action. When the controller doesn't show any reaction, any control action, that is called neutral zone. Okay, so this is called neutral zone. So in the neutral zone, the control action doesn't respond. Okay, and come to the case of multi-position. Now multi-position means so in the first category, what we observe, two position. It may be on or it may be off based upon the error signal. But here see, consider error reference is like this. Control output is 0 when error is less than minus C1. Error is less than minus C1. The output is 0. When the error is between minus E1 to E2, if the error is between like this, the output is 50%. The control output is 50%. Otherwise, if the error is greater than E2, the control output is 100%. See, more than two controller modes, more than two control actions, that is called multi-position mode. Multi-position means more than two positions. So how the controller is going to give more than two positions output P based upon the error. If for even error, controller is having some P1 output. For E2 error, controller having some other output. In between even E2 error, it gives another output. That is called multi-position. See the diagram. Here we are drawing the graph between EP refers nothing but P refers to controller error. How should we error this value? We are plotting the error versus control output P. So for reference 0, if EP greater than E2, 100%. See, this is called EP. This is called say E2. Say E2. 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 Then what happens? It is called 100%. 100%. Otherwise, if EP is less than E1, it is 0%. If EP is less than this one, it is 0%. In between these two, in between E1 and E2 like this, it shows 50% output. That is called multi-position controller mode. Okay. Next, floating controller mode. Floating controller mode means in the floating control modes, the output of see in floating control mode, the specific output of a controller is not initially determined by the error. If the error is 0, remember, if error is 0, the output will not change. The output will not change, but remains float. Remains float. Float at when whatever setting it was when the error went to 0. Error went to 0. So, in the previous understanding, if any error is 0 or any maximum value, accordingly the controller is going to be changed. But here, if error is 0, the output will not change but remains float. The control output remains float. So when the error moves off 0, the controller again begins to change. So the floating point controller mode, again we have two types: single speed and multiple speed. Single speed and multiple. In the single speed, what is the relation? Single speed controller mode, floating point controller mode, output of the control element changes at a fixed rate. Output of the controller output changes at fixed rate, constant speed. So how the constant speed? Mathematically you can write like this. Constant at a fixed rate when the error exceeds a neutral zone. So for this understanding, you can write your dp by dt equals to plus or minus kf. What is dp by dt? Rate of change of control output with time. Kf nothing but a rate constant. What is EP? Error. So if error is greater than del EP, this equation is valid. So it can be write mathematically like this. You can write like this. See the diagram. So see, this is a graph between error as well as rate of control output. In the previous graphs, we are simply plotting the graph between error and control output. But here we are writing error versus rate of change of control output. So how should be? See, if error is greater than plus del EP, the control output is 100% plus K. That means plus K. If error is less than minus del EP, it is minus K. In between minus del EP and plus del EP, error is 0. Control output is 0. So this type of controller outputs, actions may comes under floating control mode. In the floating control, there are two categories: single speed and multiple speed. Single speed means a constant speed. Come to the case, multiple speed. Multiple speed means the same case. Here we have different speed of control actions. Different speeds. See, in the previous diagram we have 0 plus K1 plus K and minus K. See, in the constant speed we have the outputs 0 plus K minus K. In the multiple speed 0 minus K1 plus K1 minus K2 plus K2 for different errors, for different range of errors, which are we going to apply for a controller. So based upon the error we applied, the control action is accordingly it responds. That's what the discontinuous controller modes. So in any control systems, the controller having a major uh, responsibility, because based upon the control actions, the whole system is going to be controlled. Okay. Okay. Next class you'll see about other control actions. Other control actions. If you have any doubts, you can ask me. Okay.